Welcome to our review session for Exam 2 for Managerial Accounting, the fall 2022 semester. So Exam 2 is this coming weekend, really starting tomorrow is the exam period, and it covers chapters 19, 20, and 21. I talked about this yesterday on the video for yesterday's live class, that there are a bunch of exercises in this practice set from chapter 19 because there really were 7 different approaches or calculations that you needed to know how to do for the exam. So we're going to go through each one of those 7. So we have 3 different methods for allocating support department costs, and then we have 4 methods for allocating joint costs of production. So that will take us through the first 7 exercises. And then you can see we have fewer exercises for the other 2 chapters. I want to remind you, if you're looking for this practice set in Cengage CNow, you have to switch off so the default is to assignments I can take now, but this is not one of those because it's not graded. So to find this, you need to go to either the link that says assignments I can practice now or all assignments. And you'll see there the Exam 2 practice set. The other reminder is these exercises that have the .algo at the end, like you see in this first one, means that these exercises are generated algorithmically. What that means is the numbers that you're seeing in my exercise may not be exactly the same as the numbers in your exercise. So the approaches I'm taking, the calculations I use will work, but you may need to do your own calculations if you're completing the exercises in your own set. So some of them you can see are not algorithmic, so those definitely, my numbers will be the same as yours. But anytime you see that .algo, you need to recognize that some or maybe all of the numbers in my exercise might be different. But the approach we use will work. And so that might actually be good practice for you if you watch and listen to the way I do it, and then try it again on your own with the numbers that you have in your exercises. These exercises are set to allow you to try them an unlimited amount of times. And so again, if you think it's helpful, you can start from scratch and redo the exercises just to make sure you got it. So all of this is not graded, and so it's totally up to you. You can jump around, you can do some but not all. It's totally up to you, whatever you find the most helpful to prepare you for this weekend's exam. As always, if you have questions on anything you see here in the video, you get stuck, I'm happy to help with any of those questions, and the best approach would probably be to send me an email to my JCC Gmail account. That's HINZ, my last name Hines, HINZCL01@sunijcc.edu. And let's get started. So as I said, our first exercises are going to be the support department cost allocation. The first one you can see from the title is the direct method. Anything you see in the exam is going to be very specific about which method it wants you to use. The direct method means that the support departments are allocated directly to the production departments. They are not allocated to each other. And so it really is 2 separate calculations. They're not dependent on each other. They're independent calculations. So Christmas Timber Inc. produces Christmas trees. The trees are produced through a cutting and pruning process, and so those are the production departments. Machine maintenance and janitorial labors are performed throughout the production process by non-production employees. Maintenance and janitorial costs are allocated based on machine hours used and number of trees in each department, respectively. The company estimates that the cutting and pruning areas typically have 21 and 49 trees, respectively, in them at one time. The company also estimates that the cutting process requires about 9 times as many machine hours as the pruning process. So we'll start with the maintenance department just because it's the first one listed here. Just want to make sure that we have to do both. Using the direct method of support department cost allocation, determine the total cost of each production department. Okay. So it's always important to read all the directions. I myself sometimes skip over things when I'm trying to do 4 things at once in the classroom. So that's my example and my warning to you of what not to do. Make sure you read every word so that you know what it's asking for. And this is asking for the total cost. It's a good idea to read the entire problem first before you even get started. Then go back and pick out the information you need to be able to do the assignment or the exercise in full, knowing this is the end result. So I know the end result is we need the total cost of each production department. So that's going to include the direct cost. So for the cutting department, it's going to include this $54,000, plus it's going to include an allocation from the maintenance and the janitorial department. I would also encourage you when you're taking the test to have maybe a notebook, some kind of a scratch paper that you can use to do your calculations so that you're not trying to maybe keep too many numbers in your head or in the memory of your calculator. So to that end, I am going to put here on the screen, because since I'm on Zoom, I can write directly on the screen and we can go from there. So this is going to help me remember what we need to put in. So we need to include the direct cost, that's $54,000 for the cutting department and just $10,000 for the pruning department. And then we'll need allocations both from the maintenance and the janitorial departments. So in other words, this, this 7,000 and this 4,000 are going to be allocated in full to each of these other 2 departments. And as I said, we'll start with the maintenance department just because it's listed first. In the direct method, these are independent calculations. It doesn't make any difference which one we do first. We'll get the same answer in the long run. Maintenance department is allocated based on machine hours used. And this is the information that it gives us, that cutting requires 9 times as many machine hours as the pruning process. So it doesn't give us exact hours, but we do know the ratio of those hours. So out of every 10 hours of work, 9 hours are for the cutting process and only 1 hour, 1 machine hour, is for the pruning process. In other words, 9/10 of the cost of the maintenance department is going to be allocated to cutting. So if I take this maintenance department 7,000 and multiply by 9/10 or 0.9 or 90%, all of those numbers are the same, mean the same thing. So 9/10, 9 out of 10 machine hours is used for the cutting department. And so I'm going to allocate $6,300 of the maintenance cost to the cutting department, and the other 1 in 10 hours, or $700, is going to be allocated to the pruning department. We then have to allocate the cost of the janitorial department, and it tells us that we're allocating that based on the number of trees. So how many trees are there in total at any given time? There are 70 trees total. Of those 70 trees, 21 of the 70, which is 3/10 or 30% of the cost, 21 out of 70, 30% of the trees are in the cutting department. Just had to make sure I was getting them in the right order. So it tells us cutting and pruning 21 and 49 respectively. So 21 out of 70 times the $4,000 is for the cutting department, and the rest, the other 70% or 49 out of 70, is going to go to the pruning department. So for janitorial, $4,000 times 30%, $1,200 worth of the cost of the janitorial department is going to be allocated to the cutting department. And then the other 70%, that is 49 out of 70 trees, times the $4,000 is $2,800. And that will be allocated to the pruning department. So if you were to add across here, maintenance, 6,300 plus 700, we've fully allocated the maintenance department. And then 1,200 plus 2,800 is 4,000. We've fully allocated the janitorial department as well. So to finish up this exercise, we just need to add the direct costs to the indirect or allocated costs to get the totals for each of the production departments. And so that's the direct method. Definitely the simplest. Order doesn't matter because we're allocating only the support departments to the production departments. We don't allocate support departments to any other support departments. Really important there that we read the, what is it actually asking for? So this asked for total cost. It could have asked for the allocation of the maintenance department. It could have asked just for the allocation of the janitorial department. It could have asked for the total allocation, meaning we just add the maintenance and janitorial together. But because this asked for total cost of the department, we knew we had to include those direct costs as well. Any questions on that?
Nope.
Drawings off the screen and we will keep going. So the next approach is the sequential method. And as I told you in class, this is sometimes called the step down method. In the sequential method, unlike the direct method, order matters because we do allocate some some support departments to other support departments. We don't allocate every support department to every other support department. Order matters, and we're going to make a decision about which one goes first. For this exercise, for the test, it's going to tell you which one goes first. But really, that's a management decision. It could be either one. So we have two support departments here, maintenance and security. We could do either one first. And so for this exercise, it tells us allocate, there we go, the support department with the highest cost first. So the security department has a higher total cost than the maintenance department. We're going to allocate the security department first. The security department then will be allocated to maintenance and to the two production departments, cutting and sewing. Then we'll allocate the maintenance department. The security department has already been zeroed out. It's fully allocated. And so the maintenance department will be allocated only to the two remaining departments. And that's why it's called the sequential or step down method. We're going to eliminate or fully allocate one department at a time. This could easily be used for a company that has multiple, not just two, but more than two support departments. That's also true for the direct method. Very easy to use that for companies that have 5, 10, however many support departments. And so let's get started with this. Again, we need to make sure we know what they're asking for. They're asking for the total cost of each production department. So again, I'm going to put a little table on the screen here. And I need to add a column for the maintenance department. And I'm going to add a column for the security department. And down here, I'm going to add a row for the security department and a row, I'm going to give myself a little bit more room. I didn't like how close they were together. Oops, not management, maintenance. Okay. So the first thing we're going to do is allocate the security department because it says to allocate the department with the highest cost first. And the security department, we need to know how we're going to allocate those. Maintenance is going to be allocated based on machine hours, and security is going to be allocated based on square footage. So as we look at, I'm just going to box these out here. So we're allocating security department first. It has the highest cost. We're going to be allocating it based on square footage. So these three that I'm boxing here in red, these are the three square footages that we're going to use. We're not allocating the security department to itself, and so we're going to ignore those square feet. We're only using the square feet for the three departments that are going to receive an allocation, receive some cost from the security department. So if we add all of those together, it's a total of 8,000 square feet. The maintenance department is 800 of those 8,000, or 10%. And so, get my text writer up here. From the security department, we're going to allocate 10% of the total cost to the maintenance department. 10% of 3,000 is $300. And then we can allocate to the cutting department, that's 3,200 square feet divided by 8,000 total, then times the 3,000 cost, that's $1,200 being allocated from security to the cutting department. And finally, for the sewing department, let me try to get these to line up a little better. To the sewing department, that's 4,000 out of the 8,000 total square feet in those red boxes. Half of the cost, 4,000 out of 800, that would be $1,500 being allocated from security to the sewing department. And let's add those across and make sure we've fully allocated the 3,000 from the security department. 1,200 plus 1,500 is 2,700 plus 300. So I'm going to show this, that we have fully allocated the security department cost. It had 3,000 in there. We took 3,000 out. There's no cost left in that security department. And now we have the maintenance department to allocate. Well, the maintenance department original cost was 2,300, but we just allocated 300 more from security. And so now the total cost in that maintenance department is 2,600, and that's how much we need to allocate out. The maintenance department is being allocated based on machine hours, and we're allocating only to the two remaining departments, the production departments, cutting and sewing. Security has already been zeroed out. We've already fully allocated that. Maintenance is only going to be allocated to the two remaining departments. And so if we add up those two machine hours that I have in the red box, 3,700 plus 5,550 is a total of 9,250 square feet. 3,700 of those, 37 divided by 9,250 is 40%. 40% of the machine hours are spent on the cutting department, and so 40% of the cost of the maintenance department is going to be allocated to cutting. 40% times the 2,600 is $1,040. Let me say that one more time. So the total cost in the maintenance department is now this 2,600. 2,300, which were the direct costs, plus the 300 that were allocated from security. So we need to fully allocate that department. And then for the sewing department, that's 5,550 hours out of the 9,250. It's the other 60%. So 60% times the $2,600 is $1,560. And if we add those together, 1,040 plus 1,560 is 2,600. And so I can just show that over here, that we have now fully allocated that department as well. All of the cost is now from the support departments has been allocated to the production departments. I'm going to add one more line here. Good thing I gave myself a little bit of extra room. Squeeze this in here for the direct costs. For cutting, the direct costs were 19,600, and for sewing 20,800. So now I can add those columns together just like we did in the previous exercise to find what we were asked to find, the total cost of each production department. So the total cost includes the direct cost plus the allocation from each support department. I'm just adding up that column right underneath where I'm recording the answers. And all of the cost for this company has been allocated to the production departments. So as I said, if you have any questions, you're welcome to ask at any time. If I don't hear anything, I will assume that everybody's good. So the sequential method is a little bit more complicated than the direct method, but still basic calculations. We just have to remember it matters which order we use when we're doing it sequentially. When we use the direct method, order does not matter. And let me get my drawings off the screen here. Now this exercise, the next exercise is the reciprocal services method. Remember, this is the one that is extra credit. So you will not see an exercise like this on the exam, but there is an extra credit problem that is very similar to this. It is optional, it's extra credit, doesn't count against you if you don't do it. It can only help your grade if you do try it. And I would encourage you to try it. Why not? Can't hurt. But it's definitely not on the exam. So this reciprocal services method is more complicated. As we saw, we did this in a couple exercises in class. It was also in the homework problem. It is more of an algebra kind of question, or rather than so much of an accounting question. And I did mention in class, the new edition of the book that just came out late spring actually doesn't cover the reciprocal services method. So apparently they recognized what I recognized the first time I used the book, which is this is a little bit more complicated than the average material for this class. So it's an important approach and it's very helpful. Unlike what I said for the direct and the sequential method, we don't really have the mathematical tools to be able to do this if there are more than 2 support departments. But we'll go ahead, we'll go through this one, and but keep in mind if you struggle with this, it's not on the exam, it's only the extra credit. So Davis Snowflake and Company produces Christmas stockings in its cutting and sewing departments. The maintenance and security departments support the production of the stockings. Costs from the maintenance department are allocated based on machine hours. We've seen that in the last 2 exercises. And costs from the security department are based on asset value. Information about each department is provided in the following table. And so, unlike the direct method where we didn't allocate support departments to other support departments at all, it only went directly to the production departments. Unlike the sequential approach where we allocated the first support department to the second support department, but not the second to the first, the reciprocal services recognizes that maintenance supports security, but security also supports maintenance. And so we end up allocating each support department to each other support department plus the production departments. And that's what makes this more complicated. And so as we saw in class, I'm going to try to give myself a little bit more white space here. As we saw in class, we need to first set up a system of equations, and then we're going to substitute one equation into the other one and solve. And again, we're asked for the production department's total costs. So we know we're going to be including their direct costs, but also the allocation from maintenance and security. So unlike the exercises that we did in class, where I think we just had to do one of the two departments' allocations to show the allocation from, say, maintenance to cutting and sewing, this is like the previous two exercises where we need to do the allocation from both support departments and then show the department total costs. So I'm going to set up down here on the bottom, just like I did in the previous two exercises, a line for their direct costs and then a line for their maintenance and security cost allocations. And put in the direct costs now. So the direct costs for the cutting department are $63,000. And for the sewing department, it is $85,000. The maintenance and security allocations are what we need to still determine. So let's go about setting up our equations. And I'm going to use M for the maintenance department and S for the security department. So M and S will be our variables. So the maintenance department costs are, there it is, $38,880 plus some part of the security department. So I'm just going to, for now, put a question mark in there, plus some part of security. And the security department's costs are $17,280 plus some part of the shouldn't have done that, plus some part of the maintenance department. And that's what we need to figure out first to set up these equations. I'm going to give myself a little bit of space there. I need to come down here. So maintenance is allocated based on machine hours. So the maintenance department is being allocated to all three of these other departments based on machine hours. And then the security department is being allocated based on asset value. And here are the relevant asset values. So I'm just going to add across. So to find the total machine hours that we're using for the allocation, 2,000 plus 6,800 plus 11,200 is 20,000 machine hours. And then the total relevant asset value is 2,000. Oh, sometimes I find myself plugging things into my calculator that's just faster to add them in your head. 2 plus 2 plus 6 is $10,000 in asset value. So looking at the security department being allocated based on asset value, the maintenance department has 2,000 out of the total of $10,000 dollars worth of asset value. That's 20% or 0.2. I'm going to try to, I don't need that zero on there. I'm going to try to sneak that in there so it kind of fits into my equation. Let me say that one more time. We're allocating the security department based on asset value. The asset value for the maintenance department is 2,000 out of the total of 10,000. That 2,000 divided by 10,000 or 0.2. 20% of the cost of security is going to be allocated to the maintenance department and added to their direct costs. For the security department, then, we have 20,000 machine hours, and we're allocating maintenance department costs to the security department based on the 2,000 machine hours for security. 2,000 out of 20,000 is 0.1 or 10%. So 10% of the total cost of the maintenance department is going to be allocated to the security department. because security has 2,000 out of the 20,000 machine hours. So there's our system of equations, and now it's just a matter of solving. We good so far?
Yes.
Okay. So in reality, it should not matter which equation that we substitute into which other equation. So we could take this, whoops, why are you not drawing? Here we go. We could take this and plug it in for M, or we could take this and plug it in for S. In reality, unfortunately, because of rounding, you just need to be really careful that you don't round off too closely. And my other comment is, if you do the extra credit and your numbers, if you don't get credit for it, but your numbers are really, really close, it probably is a rounding issue. I will try to be checking on those, but you should also feel free to just bring that to my attention if you think you did it right, but it was a rounding issue. Of course, that's always true on the exam as well. And so I'm just plugging the second equation into the first. M equals 38,880 plus 0.2. And then the part in parentheses is what we know S is equal to. And so now we have an equation with just one variable. And we're just going to go through the regular follow order of operations and solve. So I'll do this one step at a time just to make sure it's clear. I'm now going to distribute that 0.2 to each of the terms inside the parentheses so that we can get rid of those parentheses. That's the P part of PEMDAS. And so let's get rid of those parentheses. 0.2 times 17,280 is 3,456. And 0.2 times 0.1 M would be 0.02 times M. So we've now gotten rid of the parentheses by distributing that 0.2 to each term inside. Now I want to combine like terms. I'm going to combine my two constants here on the right-hand side of the equation. And at the same time, I'm going to get this M, the 0.02 M, combined with the one on the other side of the equal sign. So the way to get rid of this 0.02 M here is to subtract 0.02 M from each side. 1 M minus 0.02 M would be 0.98 M. Then combine the constants that are remaining on that right-hand side. 42,336. Finally, to get M by itself, I'm going to divide each side by 0.98. And that gives me, the maintenance department is $43,200. Now I'm going to plug that number into the second equation to find the total for the security department. S equals 17,280 plus 0.1 times M, that we now know M is 43,200. So again, just to finish this up, 0.1 times 43,200 is 4,320. Add that to the direct 17,280, and S equals 21,600. So we now have the fully allocated cost. Oops, not letting me work. There we go. M is 43,200 and S is 21,600. That's not our answer though. We now need to take those and allocate those to the cutting and sewing departments. And this is going to look just like a direct allocation that we did in our first exercise. The maintenance department is allocated based on machine hours. The cutting department has 6,800 machine hours out of 20,000. 6,800 divided by 20,000 is 34%. It's going to receive 34% of the maintenance department costs of 43,200 or 14,688. The sewing department is 11,200 of the total 20,000 machine hours. Multiply that by the 43,200 cost for the maintenance department. That's 24,192. Then we're going to do the same thing with the security department. The security department is allocated based on asset value. The cutting department has $2,000 of assets divided by the 10,000 total. That's 20% or 1/5 of the total cost of the security department that's going to be allocated to the cutting department. 2 divided by 10, 2,000 divided by 10,000 times 21,600 is 4,320. And finally, the sewing department is 6,000 out of the 10,000 total dollars of asset value times the security department, $21,600. Oops, let me move that over a little bit. $12,960 of the total cost of the security department will be allocated to the sewing department. Oops. Now we can add those together. $63,000 plus 14,688 plus 4,320 is 82,000. Oh, whoops. 008. And for the sewing department, 85,000. Whoops, one extra zero there. Plus 24,192 plus 12,960, 122,152. So again, I know this one is more complicated. That's why it's not on your exam, but it is a good idea to be familiar with it. It is an important tool in our toolkit as managerial accountants. It is really a better way, a more realistic way of allocating those support department costs, recognizing that support departments do use other support department services, and that should be reflected in the total cost. Any questions?
Nope.
Okay. Clear my drawings and we'll move on. So now we're moving into the second part of what we did in chapter 19, which is the allocation of joint costs. And again, there were 4 separate methods that we used for allocating joint costs. We're going to go through each one of those. The physical units method is probably the easiest or the most straightforward. Big Al's Inc. produces and sells various cuts of steak, including sirloin, ribeye, and T-bone. The cuts of steak are produced jointly until Big Al's cattle are butchered. That kind of makes sense. Big Al estimates that at the split off point, 10 cows yield 99 pounds of sirloin cuts, 55 pounds of ribeye cuts, and 66 pounds of T-bone cuts. Given Big Al's estimate that the joint cost of producing 10 cows worth of steak cuts is $1,500, so I'm just going to put that number down here in the total box. So it's $1,500 worth of steak cuts that we're allocating among those 3. And we're going to allocate it based on physical units. The physical units in this case are pounds. So let's see how many total pounds of steak are being produced here. So we have 99 pounds of sirloin plus 55 pounds of ribeye and 66 pounds of T-bone. So how many total pounds is that? 220 total pounds. And so we're going to allocate the $1,500 based on what portion of those total pounds is made up of each one of these steaks. So sirloin is 99 out of 220. Ribeye is 55 out of 220. And T-bone is 66 out of 220. For each one of those, we're going to multiply then by the total joint cost that we're trying to allocate. In this case, we're told it's $1,500. So that's the calculation we're doing for each line. 99 divided by 220 times 1,500 is 675. For the ribeyes, 55 out of the 220 pounds times the 1,500 total combined or joint costs. We'll allocate $375 in cost to the ribeye. And 66 out of 220 times 1,500 is 450. And then we would just want to add those three together to make sure that they do actually equal $1,500, and they do. So one point about these methods, these four different methods, in case you're wondering, well, how does a company know which one to use or which one is the right one to use? There isn't really a right or a wrong answer. If we're the company, we would want to use the one that is the most efficient, that is, it's the easiest for us to use, but at the same time, it gives us the best understanding of our true costs. The reason it's so up in the air like this, where I'm saying you could really use any one of these four approaches, is because in the long run, the total cost is going to match with what the company actually spent. And so it's an internal decision how we allocate that cost among the various products. So again, we'd want to use the one that's the most efficient. That is, it's the easiest to use while also giving us the data that we need to make business-related decisions for our company. So that one's pretty simple. After going through the reciprocal services method, it's nice to have one that's a little bit more straightforward, right? And I'll erase my writing on the screen and we'll keep going. So the next question or the next exercise is the weighted average method. And so the idea in the weighted average method is maybe they don't all take the same amount of work. And so ones that take more work, we want to allocate or assign more cost to them. So this exercise tells us that Gordon's smoothie stand makes 3 types of smoothies: blueberry lemon, orange swirl, and triple berry. Before all flavors are added, the smoothies go through a joint mixing process that costs a total of $43 per batch. So I'm going to go ahead again and enter that $43 here in the total line. And our job is going to be to split up or allocate that $43 to each of the 3 products. One batch produces 21.75 cups of blueberry lemon, 29 cups of orange swirl, and 36.25 cups of triple berry smoothies. In addition, Gordon has studiously noted that the mixing process necessary for triple berry and blueberry lemon smoothies takes twice as long as it does for orange swirl. So if it takes twice as long, they should be allocated twice as much cost, right? And so let's set up a table here to help us organize our thoughts. I'm going to just extend this line a little bit here, and we'll work across, and then we'll come back to put in our answers. So let's start with the information that we have that we're given, the cups per batch. And this is not going to line up exactly, but I'll try to do the best I can here. So 21.75 cups per batch of blueberry lemon. Keep in mind that the numbers in your exercises might be slightly different, but you're going to follow the same approach. 29 for orange and 36.25 for triple berry. And I'm going to pull that down a little bit. It's not a great lineup. So best I can do. Let's do then the weight factor that we're going to apply. And what did it tell us? Triple berry and blueberry lemon take twice as long. So I'm going to give triple berry and blueberry lemon a weight of 2, and orange swirl, which only takes half as much time as the other two, a weight of 1. Next, and let me see if I can just erase that green line so it's not in our way. So next we are going to apply that weight to come up with the weighted number of cups. I'm just going to call it weighted cups. So I'm just multiplying across. 21.75 times 2 is, 43.5 for blueberry lemon. For orange swirl, 29 times 1 is, of course, 29. And 36.25 times the weight of 2, 72.5. So now I need to add those up so we know the total weighted cups we're dealing with. So I'm just going to add down that column. And I got 145 cups total. So we can now calculate the percent that each one of those makes up of the weighted cups. So for blueberry lemon, they're 43.5 out of the 145 total weighted cups. That's 30.3 or 30%. For orange swirl, it's 29 out of the 145 cups, or 0.2 or 20%. And it better work out that triple berry is 50% because these need to add up to 100%. 72.5 divided by 145 is 50%. And so you can see that the total of that column is 100%, and that has to be the case. We have to have accounted for all of our costs. Now we are ready to allocate those costs because we have our percentages. 30% of the total cost, 30% of the $43 is going to be allocated to blueberry lemon. 0.3 times $43, $12.90. It does tell us to round to 2 decimal places, and certainly that makes sense when we're working with dollars and cents. Orange swirl gets 20% of the cost. Again, I'm using the number from this right-hand column here. 20% of $43, 0.2 times 43, $8.60 will be allocated to orange swirl, and half of the cost, 50%, or $21.50, will be allocated to triple berry. So you can see that we followed mostly the same approach as we did under the physical units method, but we did apply weights. In this case, and frequently it's based on the extra amount of work. So a product that takes more work, the mixing time takes twice as long in this exercise, is going to get a higher weight, and they're going to end up with a higher percentage of the total cost. That really is an equitable way of splitting the costs. Probably gives this company a better understanding of, how to set the price for the product, for example. Now, I'm not suggesting that this company automatically is going to charge more for the triple berry, what are these, smoothies? But based on this cost allocation, we might want to. It does yield the highest number of cups too, but it's not that much higher than orange swirl, and the costs are significantly higher. So we might want to have different prices for each one of our smoothies. That would be kind of a logistical nightmare if you're working for this company at the front counter, the smoothie stand. Any questions about that?
Nope.
Okay, on to our third approach, which is market value at split off. And so Toil and Oil, it's a cute name. Toil and Oil produces crude oil to jointly produce gasoline, diesel, and kerosene. One batch produces 3,415 gallons of gasoline, 2,732 gallons of diesel, 1,366 gallons of kerosene at a joint cost of $12,000. So again, we know it's that $12,000 that we're trying to allocate to each one of these three products. At the split off point, all products are processed further, but the estimated market price for each product at the split off point is as follows. Again, let me set up my table here so we can go through these calculations. Probably going to have the same issue as I did in the last one, that they're not going to line up quite right, but I'll do the best I can. Maybe I'll just not try to do them all in the same box. Okay, so we're going to start with the number of gallons per batch. And for gasoline, that was 3,415. For diesel, that is 2,732. And kerosene, 1,366. We are then given the market value per gallon for each one of those. So for gasoline, it's $2. Wouldn't that be nice, $2 gasoline? This is not the total cost anyway, but just reminiscing. $1 for the diesel and $3 for the kerosene. And so we can use that to find the total market value. Just multiplying across. If we have 3,415 gallons of gasoline at $2 per gallon, that's $68.30. And diesel at $1 a gallon, 2,732. And for kerosene, 1,366 gallons at $3 a gallon. Total market value, $4,098. Because we're using that market value as our allocation tool, we need to know what is the total market value. So I'm going to add that column. Put my total down here. $13,660. And then we can find the percent of the total market value. So $68.30 is the market value of the gasoline at the split off point, divided by the total $13,660. 50% of the value of that product comes from gasoline. $27.32 is the market value of the diesel, divided by 13,660. 20% of the value is for the diesel. And we know then the kerosene must be 30% because these have to total the 100, but of course you can check it. 4,098 divided by 13,660. Now we're ready to do the allocation. If 50% of the value comes from the gasoline, then 50% of the cost would be allocated to gasoline. 50% times 12,000, 6,000. Another 20% comes from the diesel. 20% of the total is $2,400. And finally, 30% or 3,600, 30% of the 12,000 or 3,600 is the cost that, is the cost that we will allocate to kerosene. We want to add this column, make sure it does equal the 12,000, make sure we fully allocated those joint costs and not allocated too much. And so that's the market value at split off method. And in the absence of questions, we'll keep going. I'm very mindful of our time. I don't want to, we're already bumping up against 1 hour here. So joint cost allocation net realizable value method. So let me again set up my table here. Okay. Lily's Lemonade Stand makes 3 types of lemonade: pure, raspberry, and strawberry. The lemonade is produced through a joint mixing process that costs a total of $30 per batch. And so we know that it's the $30 joint cost that we need to allocate to each of the products. After the split off point, all 3 lemonades can be sold for 80 cents per cup, but strawberry and raspberry lemonade can be processed further by adding artificial flavoring and coloring and sold for 95 cents and $1 per cup respectively. It is estimated that these additional processing costs are 75 cents and $1.80 per batch for strawberry and raspberry lemonade respectively. Allocate the joint cost of production to each product using the net realizable value method. And so what makes this different from the split off method, value at split off, is we're projecting farther into the future rather than what is it worth when we're done doing the joint processing, what will it be worth in the future and how much extra cost is that going to include? And so let me get my writing utensil up here. And so part of this technique is comparing the market value at split off to the greater of that market value or the net realizable value. And but in the interest of time, I'm just going to show you the net realizable value part of this because it's going to be the method that we use for this exercise. So let me show you just the net realizable value. So the market price, let me put in the cups first, the cups per batch that we are told. So the cups are 32 of pure lemonade, 21 of strawberry, and 21 of raspberry. And the market price per cup I'm just going to combine this into into one column. Market price minus additional cost. Like that. So I can do this in one less step. So there we go. The market price per cup is 80 cents. Let's see here. But strawberry and lemonade sold for 95 cents. Oops, pure lemonade is 80 cents. Forgot which line I was on. Pure lemonade is 80 cents. There is no additional cost because that is the product at the split off point. For strawberry lemonade, it's 95 cents, but the additional cost per batch is 75 cents. Oh, per batch. It's not additional cost per cup. Sorry, I can't do it this way because I have to do that 75 cents in total. So let me just take out ignore this additional cost part. I was thinking those were additional costs per cup. We're going to have to do this a little bit. I am going to have to do the extra step here. So raspberry lemonade sells for $1 per cup. Okay. So the total value smaller, so I'm not taking up so many columns. The total market value, 32 cups, 32 cups at 80 cents each. For pure lemonade is $25.60. Sorry if I just added to your confusion, but I thought those extra costs were per cup. 21 cups at 95 cents. For the strawberry lemonade, $19.95. And 21 cups at $1 would of course be $21. Now we can, so that's the total market value per batch. Now we can subtract the additional cost. For the pure lemonade, there is no additional cost. For the strawberry lemonade, it is 75 cents. And for the raspberry lemonade, it is $1.80. So finally, we are at the net realizable value. How much can we actually get from this product? $25.60 for the pure lemonade, because there is no additional cost. For the strawberry lemonade, we are going to realize only $19.20. We have to subtract that 75 cents in additional cost. And for the raspberry lemonade, we also have to subtract the $1.80, which is $19.20. And so the amount that we make from the raspberry lemonade, even though we sell it for more, it costs more to produce. And so the net realizable value, the actual extra value, is eaten up by that extra cost of production. So now we can do the allocation. 25, let's do our percentages. I'll do one more column here for the percents. So the percentage of the total value, we put in the total here. So the total realizable value is $64. And now we can calculate our percent. $25.60 divided by $64. 40% of the net realizable value is from the pure lemonade. And then of course the other two are going to be the same. They're $19.20 divided by $64, and that will be 30% each. Again, that column has to add to 100%. Now we can do our allocation. 40% of the total cost is going to 40% of the total cost is going to go to pure lemonade, because 40% of the net realizable value is for the pure lemonade. That's $12. 40% times $30. Then, well, click here. 30% times $30. $9 each will go to the strawberry and the raspberry lemonade. And then, just as we did in the last exercises, we want to add those three together, make sure it does equal the $30, make sure we have fully allocated that cost. So that's by far the largest part of the practice set. That is the allocation of support departments using the 3 methods, and allocation of joint costs using 4 methods. Any questions about that?
Nope.
So let's keep going. I am going to run up against a hard stop because I do have a class this morning. So we need to keep going. I don't want to run out of time before we finish this. All right, so our next exercise is the high-low method. This is to separate a mixed cost into its fixed and variable components. The way I described it, the way we thought about it in class, was it's really using the slope-intercept form of a line. Unlike the exercises we did in class, there are actually 6 months worth of data here, so it does take a little bit more insight to recognize the highest and the lowest points. So let's go ahead and identify those. Activity base is a measure of railroad operating activity termed gross ton miles, which is the total number of tons multiplied by the miles moved. We don't really need to know that, but it's interesting information. Our highest month then would be right here, June. We had the highest gross tonnage and miles and the highest cost. And the lowest month would be March. And so what we're trying to determine is if we can use gross ton miles to predict our transportation costs. So if I were to put this on an XY axis, we would be using gross ton miles on the X axis as the independent variable and transportation cost on the Y axis. So as we use the slope-intercept form of the line, it is important that we identify which one is the X, or the predictor, or the independent variable, and what is it we're trying to predict, which is in this case the total transportation cost. So we'll start with the slope, which, as I described it in class, the slope is the variable cost per unit. And that's going to be the change in total cost. So from the high to the low point, $975,900 minus $669,000. So the change in total cost divided by the change in the total gross ton miles. So if you're plugging this into your calculator, make sure you use the grouping symbol so that you're dividing that numerator by the whole, whoops, I'll get it first, by the whole denominator. And what I got was $3.10 per gross ton mile. And that's going to be our variable cost. We can then plug this into the formula. Again, if you think of it as the slope-intercept form of the line, it makes it, I think, a little bit easier to see what we need to do next. Doesn't matter which point you use, the high or the low point, you're going to get the same answer. So I recommend using the low point just because the numbers are smaller. So it makes our calculation maybe easier. So I'm plugging in the Y is the total cost. The slope is what we just calculated, $310 per gross ton mile. The X is the gross ton miles that correspond with that total cost. And it doesn't matter which one we use. And then the B part is the fixed cost. Oops, fixed cost. So now it's just a matter of solving. $3.10 per mile. If we had 158,000 gross ton miles, then the total variable cost would be 489,800. If we subtract that from the total 669,000. 669,000 was the total cost in the month of March, and 489,800 of that was the variable cost. Then the total fixed cost would need to be $179,200. So we first had to calculate the variable cost per mile, then subtract that variable cost from either point, you can use May, March or June, subtract the variable cost from the total cost, and that leaves us with the fixed cost. So that's the high-low method. It's really not relevant to the calculation that this is for a service company. It works just as well for a merchandising or a manufacturing company as well. And let's keep going. Contribution margin and contribution margin ratio. For a recent year, McDonald's, that MCD is the trading symbol for McDonald's, the stock trading symbol. Company-owned restaurants had the following sales and expenses. Assume that the variable costs consist of food and packaging, payroll, and 40% of the general, selling, and administrative expenses. I'm just going to make a note of those here. So variable costs are food and packaging. Label that a variable cost. Payroll is also a variable cost. Occupancy, rent, depreciation, etc. is a fixed cost then, because it's not specified as a variable cost. And this general, selling, and administrative, 40% of that, 40% of 4,000 would be 1,600 is the variable portion, and the fixed cost would be whatever's left, 2,400. The other 60% would be a fixed cost. So we're asked, what is McDonald's contribution margin? Our formula for contribution margin is sales minus variable costs. So our sales are given as 27,200. We need to subtract from that our variable costs. And we have 9,996 plus 6,900 plus 1,600 of that general, selling, and administrative expense. And if I did the math right, I got $8,704 million would be our contribution margin. The contribution margin ratio is that contribution margin in dollars divided by the sales in dollars. So 8,704 divided by 27,200 would be 32%. And finally, how much would operating income increase if same-store sales increased by 1,000, sorry, I'm just going to call it billion, 1,600,000,000 for the coming year with no change in the contribution margin ratio or fixed costs. Round your answer to the closest million. Okay, so how do we want to think about this? Contribution margin ratio is what percent of each dollar in sales the company has left after covering the variable costs. So of this 16, I don't know why I keep saying that, 1,600,000,000, because I don't want to say 1,600 million, that doesn't make any sense. Doesn't sound right to me. So we've already covered all of the fixed costs. We know that because we have a positive operating income. We don't even really need to know that to answer this question though. How much would operating income increase if the sales increased by this amount? If they increase by that amount and we get to keep 32% of that, what is 32% of 1,600? 1,600 times 32% is 512 million. How did I find that? I took the sales multiplied by the contribution margin ratio. That tells us how much more contribution margin they would have if their sales increased by that amount. Make sense? So contribution margin ratio, or contribution margin, is how much we have in dollars left of the selling cost, or the selling price, the sales, after we cover the variable costs. Fixed costs remain the same, and we increase our sales by 16 million, we get to keep 32% of that, 1,600 million. We get to keep 32% of that, that's 512 million. Just trying to give you a couple different ways of thinking about what those numbers mean. And I think we are now in chapter 21. So in chapter 21, and I'm not going to have time, unfortunately, to go through all three of these. So let me just talk about all three of these quickly before I run out of time here. So chapter 21 covered absorption versus variable costing. We know that absorption costing is what is required for GAAP. What that means is the fixed costs are treated as a product cost, and so they get attached to the product itself. If the product hasn't been sold, then those fixed costs are sitting in inventory. And so we need to be very careful about what that incentivizes, what that encourages management to do. We don't want to produce for inventory. We've been talking about that a lot in class. We want to produce because we have a sale. We have someone who's going to buy it from us. So what happened in this exercise, they produced just because they could, not because they had a buyer for that product. And so their ending inventory increased. Under absorption costing, then the fixed cost for those units would end up in ending inventory. Under variable costing, those fixed costs would be expensed. They're treated as period costs. They would be expensed during the month that they were actually incurred. And so when inventory goes up, absorption costing has a higher income than variable costing, because variable costing is going to include all of those fixed costs on the income statement. Again, absorption costing is required for GAAP. Variable costing is for internal use only for decision-making purposes. So in this exercise, you're asked to produce the two different income statements. What you should see is that the income is higher on the absorption costing because of that ending inventory value. Let's take a look at the others, and then I'll be glad to answer any questions you have about these. The product profitability analysis is using the contribution margin. We talked about manufacturing margin in this where we separate the manufacturing costs, again, the fixed from the variable. And so the manufacturing margin is sales minus variable product cost. And then we subtract the variable selling and administrative or operating expenses to get to that contribution margin. Then we subtract the fixed cost to get to the bottom line, the net income. And so in this exercise, we are asked to produce a contribution margin by product report. So you already have those split. And so it's going to point out to you which one of these actually is contributing more to the bottom line of the company by keeping in mind the difference between fixed and variable costs that go up or down as our volume changes. And you'll be able to answer a couple questions down here at the bottom about that. And then finally, the segment contribution margin analysis. And this is this whole chapter we just covered last week, so hopefully this is a little bit fresher in your mind. And so trying these on your own is not going to be as challenging maybe as the information we covered back before October break in chapter 19. So in this exercise, be careful how you round. Round to whole percents. That could make your answer be wrong if you don't round as directed here. And we're asked to determine the contribution margin and the contribution margin ratio for each segment, given the information we have here. So that should be relatively straightforward. We have the total sales. We know what percent of those are variable costs. So, you know, if 26% is variable cost and 74% is the contribution margin. And you can calculate the variable cost by multiplying the 26% times the sales for that division. And then again, answer a couple questions. So before we end, do you have any questions about what's asked for in these 3 exercises? I again apologize that I can't stay and I didn't have time to go over all of them.
Nope.
Okay, I'm going to stop the recording.